Hey YouTube, welcome to the first episode of my Leetcode series. In this series, I'm going to be taking you through as many Leetcode problems as I can. And to start off with, we're doing this TwoSum problem. So let me read the problem and I'll give you my thoughts. Given an array of integers, nums, and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. So basically what it's saying is that it's going to give you an integer array called nums, and it's going to give you a target with a value. So in this example right here, we have 2, 7, 11, and 15, and we have the target equal to 9. So we know we can add 2 and 7 to get to 9. So we return their indices, which are 0 and 1, to get the solution. And anytime we're counting in computer science, we start our indices at 0. So this would be the 0th index, and this will be the first. So we return 0 and 1. In this example, we have 3, 2, and 4. So we know that 2 and 4 add up to get 6, and we return the indices 1 and 2. And you might be wondering, why didn't we just use 3 and add 3 with 3? Well, if you look up, it says you may not use the same element twice. So even though in this example right here, we're using 3 and 3, this is actually not the same element. So we can add 3 and 3 to get 6, and we would return 0 and 1. And here are our constraints. So how would I go about solving this problem? Well, there's actually two solutions. One is a more naive solution, and that would just be to start with one number and compare it to every other number, move on to the next number, compare it to every number, and so on and so forth. So let me show you what I mean. Let's say we had an array, and the array went like 3, 5, 7, and 11. And we were looking for the target of 12. A brute force solution would be to start at 3, compare 3 with 5, which gives us 8. That doesn't work. Compare 3 with 7, which gives us 10, which doesn't work. Then compare 3 with 11, which gives us 14, doesn't work. And then we move on to 5. Then we would compare 5 with 7, which gives us 12, and we've got our target. But notice when I started comparing with 5, I didn't compare 5 with 3 because we already compared 3 and 5. So I started at 5 and I started comparing with the numbers after. So how would we code this? We would first need a for loop, and this loop will be responsible for the first iteration of our numbers. So we're going to loop through the nums.length, which is the length of all the numbers. And then we're going to have a second for loop for the second number that we're going to add this to. Then from here, we're going to add the two numbers. And we're going to compare it to the target. And this should be an if, not a for. And if the number at index I plus the number at index j is equal to the target, then we're going to simply return the pair that we found. And let's submit this code. And you'll see that we only passed 49 out of our 60 test cases. Why did this happen? Well, a common pitfall, like I mentioned earlier, is when we move on to the second number in our comparison, is to go back and compare 5 with 3, for instance, when we already did that comparison. So here in our second for loop, we have to set the value of j to I, which is going to be the numbers we already looped through, plus 1, because like this rule states, you may not use the same element twice. So we can compare two of the same elements. That's why we do plus 1. Now if I submit this code, you'll see that our solution was accepted, but we only beat 47.43% of the users with JavaScript. What does that mean? It means our runtime is really slow. Now why is that? Well, that's because we're using two nested for loops. And when you have two nested for loops, you actually multiply their time complexity. So the time complexity of this is O of n times O of n, giving us O of n squared. So we need to find a solution that's going to beat this O of n squared runtime. Alright, so now it's time to implement our solution using a hash map. So what we're going to do is we're going to loop through this array, and for every single element, we're going to store that as an entry in our hash map. So if we're starting at 3, we would store the key 3, which returns a value of the index. The same thing for 5, we would store the key 5, returns the value 1, and so on and so forth. And while we're doing this, we're also going to be looking for a complement pair. Now, what is a complement pair? A complement pair is the number we would need to add to this element in order to get the target. So the complement pair is going to be the value minus the target. And then every time we're looping, we're going to check if the complement pair exists. And if it does, then we know we have a match because the complement pair added with the element is going to give you the target. So what do I mean? We're going to start at 3. We're going to store this in our hash map. Then we're going to look for the key of 9. So if the key of 9 exists, we're going to return that value, and we're going to return the value that the key of 3 emits. But we don't have a key of 9, so we move forward. We store 5 in our hash map with a key of 5, which returns 1. And then we're going to look for a key of 7. If a key of 7 exists, then we're going to return the value in the key of 5 and the value of the key of 7. But we haven't came across 7 yet, so we're going to move forward. Now for the next element, we're going to store 7 in our hash map, and then we're going to look for a key of 5, which does exist. And we know 7 plus 5 equal 12, so that's going to be our answer. And the key of 7 is going to give you the index value 2, and the key of 5 is going to give you the index value 1. So we know that 2 and 1 is our answer. So let's code this. To start, we're going to need to create a hash map. So we can say let map equals new map. This is how we create a hash map. Then we need to loop through every single value in our array. Then we're going to set a temp variable equal to the current value. And right away, we're going to define its complement pair. And then we're going to check if we've seen that complement pair before. So if complement pair is in our map, then we're going to return what we found, because we'll automatically know that we found a match. So map of complement pair and I, which is our current index. But if we didn't find our complement pair, then we're simply going to add our temporary variable to the hash map. And if we submit, we'll see we got an error. What's wrong? So what went wrong is that I returned our pair in regular brackets when I should have used square brackets. So if I press submit now, we'll see that our solution is accepted, and we beat 93.81% of users with JavaScript. So why is this solution faster? So you can see we're only looping once through our entire array, which gives this a time complexity of O of n. But since we're creating a new map, the space complexity is also going to be, in our brute force solution, the space complexity was actually better. It was O of 1 because we weren't creating a map. But in my opinion, I feel like that's worth it because the code is going to run much faster, and O of n is also super lightweight because the space complexity of O of n isn't that bad anyway. Anyways, guys, that's going to wrap things up for today. I hope that was easy to understand, and have a good day, everyone.